One of the engines in Amazon RDS is Amazon Aurora. So let's focus on why we need Amazon Aurora. What is the use case for it? Why AWS has to come up with a newer database when we had so many databases already available? Let's focus on that use case. If I have to decide on what database I'm going to use for my application, I have two choices. One, I could use a commercial database. These commercial databases are your Oracle or Microsoft SQL Server, very feature rich, huge performance available, like you could run a very enterprise grade workload on that, but the cost associated with them is also very high. So if I do not want to pay that much of money or my project limitations are, maybe I would look for some open source alternative. Commonly people use MySQL, MariaDB, PostgreSQL, which may give you the features you are expecting, but not that much which the commercial was offering. But the price point is very lucrative because you are getting a database which is having very less cost compared to commercial databases. Yes, you are compromising on some feature and performance. So that is one reason. So either you are paying more money or you are compromising on feature. You have to always find a balance between them. Why can't we have both? And that was the idea behind Amazon Aurora. So idea is Amazon Aurora would give you the same feature rich technology which other commercial databases offer, like going to a millisecond latency or offering you the scalability of the databases, but at the lower price point than your commercial databases. So feature rich, giving you lots of feature and performance you are expecting from commercial databases, but on a lower cost price point. So that's why Amazon Aurora can be a very useful service for lots of workload. Another reason was these standard databases I'm talking about, when Oracle, MySQL, or any open source, they were not initially designed for cloud. Right? Cloud has a different way of scaling, and cloud scale and availability zone and then redundancy and then high availability plus your durability is completely different than on-prem world. These traditional databases were designed for on-prem, and then they launched the cloud version, but the engine behind the scene was still leveraging the basic feature which on-prem provide and was not able to leverage the advanced feature which a cloud service may provide. So there was a gap. Aurora is a cloud native database. It is designed for cloud-based workload, and it incorporates all the best practices of durability, high availability, and then monitoring, which you may expect into a cloud application. So that's why Aurora can be a very nice use case for lots of application moving forward. Now, in Amazon Aurora, another benefit we get that there are different flavors of Amazon Aurora available. This is not a database training, so I will not go into detail of each of them, but I'll just give you an idea that these are the different flavors available. You may have a single master cluster, a multi-master cluster if your workload is. Global databases can be deployed across multiple regions if the need be, and you can even run in a serverless fashion, so you do not pay for consistently keeping your database server running. So much cost effective for workload where you do not need consistent performance. So as you could see, there are lots of flavors available for Amazon Aurora, and depending on your use case, you could select any of them. I'll talk about the basics that how we are able to provide this kind of scalability and durability. In traditional databases, what happens that your database node or database instance has both things, CPU or compute, that's the best way to write it, and it has your storage capability. So one node is doing this and they are tightly coupled with each other. They are working together. What Amazon Aurora is trying to do, Amazon Aurora is trying to keep the storage node separate or storage layer separate and your compute layer separate. So you could expand the storage layer and you could expand this compute layer independently. That is the main benefit which Aurora allows you, and that's how it can leverage the benefit of cloud scale application. Let's see how behind the scene the data is stored. This is a high level overview. What we are seeing here is a region, and in that region we have deployed a Aurora cluster. So whenever you deploy, you create a Aurora cluster. That cluster may have only one node in that or may have multiple nodes in that depends. Let's keep it simple. Let's consider we started initially and we deployed an Aurora cluster. In that cluster, the storage layer is automatically spread across multiple availability zone as we see here. So we are trying to separate compute and storage layers, right? Compute layer is separate, storage layer is separate as we see here. Plus, we have this drop in compatibility with MySQL and PostgreSQL. So if you're today using MySQL or Postgres-based solution, you could tomorrow replace the backend with Amazon Aurora and your program won't see any changes. Almost every feature would work as it was working for your traditional workload. So that drop in compatibility is there. To ensure durability and to leverage the benefit of cloud, we have 6-way replication across 3 AZs. So if you see, 6 copies of my data is being maintained, so I would always have high durability and high availability of my data, and you do not have to work on replicating the data. Everything is taken care by Aurora storage layer, which is spread across 3 availability zone, and all the replication, all the recovery will be done automatically by the storage layer in case any of the node fails. Basically, these data copies are running on Aurora nodes or Aurora servers behind the scenes. So there is Aurora server here, another server which has a copy, and there are thousands of servers powering this particular storage layer, and that can expand to a huge volume if the need be. So automatically your data is 6-way replicated across 3 AZs. What you also see here that this node here is represented as RW, which is a read-write copy, or this is your read-write endpoint. So I could decide to run it. Let's say I decided to run it into availability zone 3. So my application, whenever we have to read and write, I would be making a connection to this particular endpoint. And my application may be running across multiple availability zone or across region. They can talk to this particular endpoint I'm exposing, right? Plus, if I have some application, maybe in a different availability zone, and they also need to read data, that time they could take care of reading the data from a local endpoint which is visible to you. So that is how we can have multiple read-only endpoints, and maybe we can have one read-write copy if required. So we may have multiple read-only instances, and we can have one read-write instance. This is a design of a single master Aurora cluster. Another benefit is its automatic monitoring and failover happens here. What I mean by this. So let's say this is my situation where I have a read-write copy and I have 2 read copies running. For whatever reason, let's say this copy goes bad or this availability zone dies, what Amazon Aurora would do? If a read-only copy exists, it would be promoted to be your read-write copy. And it will be done automatically. You do not have to do anything. And your endpoint will be now pointing to this, so you do not have to make any changes in the application layer when your read replica has been promoted to a read-write copy. That happens automatically. The endpoint which was initially pointing here, it is now pointing to this location, so you do not need to make any changes. What if I had only one node? So if only one node was there and it is down, it would automatically create another node in the healthy availability zone and keep your application running. So these are some of the benefit of automatic monitoring and failover which you could use with Amazon Aurora. Right. And getting started with Amazon Aurora is very easy. The process remains the same. I am coming into my Amazon RDS, Amazon application console or management console, and here I would be looking for my service which is RDS, and in that I would be selecting what type of Amazon Aurora I want to deploy. Is it MySQL compatible or is it PostgreSQL compatible? You decide and provide same information what you expect for a database server, and your database would get ready based on the information you provide. So currently I do not have any databases running. Let me go ahead and deploy a database here. I am creating a database, right? You would provide the similar basic information like cluster name and then instance name and maybe size of the instances, and you would be getting your Aurora database running. One thing you have to be aware that we deploy a cluster, and that cluster may have only one node, or it may have multiple nodes inside. Shouldn't be a problem at all. So if you see here, here is one engine which is Aurora MySQL compatible, and second Amazon Aurora Postgres compatible. It is purely up to you. And if you read this information, that's what we are saying here, up to 15 read replica, lag under 10 milliseconds. So the storage layer would take care of replication, and that's why lag will be under 10 milliseconds, which is a nice thing. Even if you have huge workload, you could have this kind of a lag. So I'm starting with Aurora MySQL compatible. I would select some information like which version of MySQL I'm looking for, and as you could see there are different versions available. And if you remember the flavors I talked about, so there is a single master way of deploying Amazon Aurora. There is another way called multi-master. We can also have something called parallel query. Maybe we can have a global database deployed, and then there are serverless versions also available for the same type of MySQL version. So I selected MySQL. For the template, I would select production or dev test. It purely depends on my use case. Here I am specifying the cluster. So let's call it db-cluster01. So this will be the overall name of the Aurora cluster. Obviously, I would need some username and password. So I will auto generate passwords here. That is completely okay. Then I would be selecting the instance type. So I am selecting here to keep cost low burst stable instances dbt3.small instance. That is good enough for me to get started. Here is my option to select multi-AZ, or I could say don't create Aurora replica. So let's get started without creating it first. Default information about connectivity, I'm using default VPC and default subnet group, not exposing it to public. I may have added a security group, and let's keep it into 1A availability zone, and I'm now happy to deploy this Aurora service here. You could see more things here, like I want to create a database on top of it if the need be, or I want to perform backup at a specific time encryption. So these settings are similar to a Amazon RDS database. Only difference here is the engine type now is Amazon Aurora MySQL compatible. I will click on create database. It may take little time to get the database ready, cluster ready, and I would pause the video and come back to it once this cluster gets ready. So here you could see my cluster is getting ready. So here is my cluster identifier, and though I have not selected the instance, you could see here this one is treated as my reader instance. We'll come back to that in a minute once it gets deployed properly. Currently it is creating. Let me draw that what is actually cluster here. Cluster is representation of a logical group of instances. So this is my Aurora cluster. What I will get, I would get a cluster endpoint. Cluster endpoint would be the endpoint where I would have my application connect, and that would be then going to my backend instances. So instances are node, your EC2 instances behind the scene on which your Aurora engine is running, and they are currently accessed by the endpoint we have created. So cluster is a logical unit. Within that, your instances are running. You can have instance endpoint also. We will see that in a minute, or you will be talking to a cluster endpoint. Right? If I am deploying my cluster with only one instance, this instance would take care of read and write both type of traffic. Right? Because I have only one endpoint, so I would only be getting one endpoint for both type of request, read and read. If I am expanding this cluster, let me draw that. So if I say I am going to create a cluster in which I would be having one read write endpoint, and then I would be adding more read only copies. You could have up to 15, so shouldn't be a problem. Read write, read, read and read. And obviously you can put them across multiple availability zones. Still there would be a cluster endpoint. Cluster endpoint will be pointing here, which is accepting my read and write request, right? And I would be then having a reader endpoint created for me. Now reader endpoint is a way of load balancing across multiple readers. So this is my reader endpoint. Through this reader endpoint, I would point all my application who wants to perform read operation like a reporting service or a dashboarding service to this reader endpoint. This reader endpoint behind the scene is a type of load balancer. So request comes to it, it would forward request in a fashion to multiple instances behind it. If I have 3, my request will be connections will be forwarded to all of them. Right. So that is a good way. I'm not trying to talk to individual nodes. If I add more nodes behind the scene, more instances behind the scene in my cluster, I should be able to have them behind my reader endpoint. Right. So that is the use of a reader endpoint. One thing to be aware here, that this load balancing which is happening here is for your connections. It is not distributing your query. So if you have a query which has to process, let's say 900 records, that doesn't mean that 300 will be processed by this one and then this and this. No, this one is a connection load balancing. So if you have 10 connections coming, or let's say 12 connections coming in, 4 will go here, 4 will go here, 4 will go here. This connection may read 100 GB of data, that may read 10 GB, that may read 2 GB. It doesn't matter. This load balancing is your connection load balancing, not your query load balancing. So just be aware about this factor. So what you have here is your single master Aurora cluster. Right. So this is your single master Aurora cluster which we are having here. I've depicted the same thing into slides. So while this is happening, while my node is getting ready, let's go ahead and see the slide deck so that you will have a better idea on that. So see this, sorry, here. So this is my cluster endpoint. This is currently pointing to the read write copy because I have a single Aurora instance here. I have deployed another instance, which I'll show you in a demo in a minute, which will be having my cluster endpoint still pointing to read write copy, and I would have my read only endpoint, which is currently pointing to this one single instance behind the scene. If I have Amazon Aurora cluster with multiple Aurora instance in that, cluster endpoint would still be pointing to the read write copy, but my read only endpoint is now auto load balancing across these availability zones instances which I have deployed. Right? And you could decide them to put it anywhere into availability zone, should not be a problem. This design you are seeing here is a single master Amazon Aurora cluster, which is most commonly used design. There are more ways of deploying thing in a global table, and then you can have multi-master. I'm not talking about that in this particular training, but yes, I will share some link where you can get more details on that. The last statement here is important. In a single master cluster, a single DB instance perform all write operation and other DB instances are read only. So this is what we see here. If the writer DB instance becomes unavailable, a failover mechanism promote one of the read-only instance to be the new writer. So let's say if this was my case, in this way, if RW instance goes down, what is going to happen? You might have guessed that this read-only will automatically become read-write, and your connection endpoint will start pointing here. Read-only is still pointing here. Right. In this case, same thing. If read-only goes down, one of them will become read-only. This will be pointing here, and your read-only endpoint is already pointing here. So that is how your Aurora cluster would manage the failover, and it is all done automatically behind the scene. You may get an entry in the log when it happens, but you do not have to manually promote anyone to become a read replica. Okay, so hope this is clear. Let me go ahead and check if my cluster has been ready by this time. So we successfully created database DB cluster 01 if you see here. So see this one. This is my DB cluster 01. Regional cluster, MySQL, US East 1, that is my region. 1A is where my instance is running. Instance is dbt3.small, one instance, and it is still into the status of creating. And obviously this has to be within a VPC, and it is not currently a multi-AZ instance. So this is what I am getting here. If I want, I could change its name, which I will do in a minute, so that it would be much easier for us to understand what is happening behind the scene. Let me close this information here at the top. We have generated your database master password. So master password detail is there. I'm closing it. I can recreate if the need be. And if you see this thing here, see this. I have my cluster, and this is my cluster endpoint, DB cluster 01, which is taking care of write. And this one is also taking care of reader because there is only one instance behind the scene, and both the work is being done by this particular instance. Once this instance gets ready, I would go ahead and create one more read only, or maybe two of them, and we will then see that how these endpoint actually change. So let's give it a minute, and by that time hopefully this will also be available, and then we will move forward and create one more reader. All right, so now my DB instance is ready, as we could see here. And obviously, if you want, you could name it little differently, so it would be much easier for us to identify it. So let me go ahead and modify its name. Cluster name can also be modified. I'm keeping it db cluster 01, and then this is the instance once inside, which I'm trying to modify right now. It is just to identify that thing easily. Your endpoint would not be changing. So I'm modifying the db instance identifier. Let's call it read write instance just for sake of it, and this is belonging to db cluster 01. That's completely fine. I would go ahead and apply these changes right now. You have option to apply immediately or next maintenance window, same like RDS. I am applying these changes right now. It will take little time and then it would be ready. While this is happening, I could also go ahead and say I want to modify or add something as a read replica. So see this, I could add a reader. As you see, AWS region option is there also. Plus you could create cross region replica. That is also possible. Blue green, create clone of that, snapshot, restore, export to S3. Auto scaling can be added for replica, RDS proxy server. So these are standard option. Right now I am interested to add just a reader endpoint for it. So you are creating a replica DB instance from the source DB. This new DB instance will have the source DB instance security group and DB parameter groups. So if you have added any ports to be opened into the security group, they would be followed along here, and any parameters you have used for customizing it, that would also be displayed here. So let me call it read only 01. That is my instance. Let's make it a little easier. Instance 01. I could have selected a different type of instance if I want to. See this? So that can be different instance types. I could have selected different region. I have selected the same as of now, and connectivity. And let's keep this replica into 1B. My read write is in 1A, and I'm keeping this into 1B plus additional information, upgrade information, and I would say add reader. 1A, US East 1C, 1D. The availability on request is not supported by the DB cluster. So no problem. Let's select 1C and 1D. Maybe there's a challenge here could be that maybe the instance type I selected is right now not available in that availability zone which I have selected. Very rare, but yes, it can happen. So let's put it into 1C and hopefully this error would go away. Done. And now my replica creation has started. If you see, it is read write instance, and this is read only instance 01, which is now getting ready for me. Okay, so we'll come back once this instance gets ready and I'll show you the endpoint associated with it. So my read only instance 01 is ready. Just for sake of this demo, I would add one more read only instance, calling it 02, and then I would let it finish, and I'll explain that afterwards about endpoint which we have just created. So give me a minute, I'll get it ready and I'll come back to this video recording. So by the power of pause and resume of the video, we could see both the instances are ready now. So total we have 3 instances in my DB cluster 01, one read write, 2 read only. Let's see how the endpoint looks. So be aware that we are exploring first the cluster endpoint. So if I'm going here in connectivity and security, I see 2 endpoint. For this cluster, one endpoint is called db-cluster01, which is my writer instance, and we got another one which is called db cluster 01 cluster ro with a random name useastrds.amazon.com. Now if you would send request to this, obviously this writer instance would be responding. So you send request to cluster and the instance behind the scene respond. But if I would be sending request to this endpoint, then any of these two would be responding to me behind the scene. And if you want, you could also make connection to individual instances, right? In very rare case, if you want to say, I want to only talk to read only instance 02, so that is also possible because every instance have their own endpoint. So see this is a unique endpoint for the instance level endpoint. Again, this one is a instance level endpoint, read only instance 01, and similarly, this one also has a instance level endpoint as we see, and then there are cluster level endpoint. So read-only endpoint here will automatically distribute load to these or distribute connection to these two, and read-write will only be sending request here. So I hope this one is clear and you have a better idea on how Amazon Aurora actually works behind the scene. What I have also included into the content is the detail about Amazon Aurora, a single page talking about when to use it, why to use it, who, how kind of a stuff. Plus, I have also included information about Amazon Aurora Serverless. This is also a very unique offering in which you do not have to pay for consistently running workload or consistently running databases. So if sometime you have application activity, you want to only have your database pay, you want to pay only for database that time, then you would utilize Amazon Aurora Serverless. So check this. Current version of Amazon Aurora Serverless is version 2. Initially it was version 1, and obviously V2 has more capabilities added to it. So I wish you all the best, and I'll talk to you in the next chapter. Thank you.